Okay, today we are going to start another new chapter, rotation. That is also very important. This moment of inertia, radius of gyration, they ask the torque. So these things are very important. So we are going to start rotation. So first concept is torque. What is the formula for torque? What is torque? Rotating effect of force. If you apply any force, like this is a pen, if I apply any force and it rotates, then we say that we are applying torque. Correct? So rotating effect of force. So torque formula is R cross F. I will tell you what are these things. Okay. Like suppose this is the rod. This is the center of rotation. Correct? You are applying force here at this point, like this. Correct? So they will say what is the torque? So this is the center of rotation. So torque formula is R cross F, or RF. A cross B is what? AB sin theta. So R cross F is RF sin theta. Now what is R? What is F? What is sin theta? That you need to understand. What is R? Means from the center of rotation, like this rod will rotate now. I said now, if you apply force like this, so this will rotate. This is the rod. If you are applying force like this will rotate. So from the center of rotation, at what point you are applying the force, that is R. From the center of rotation, you have to draw a vector to the point where you are applying the force. This is your R. This is your R vector, and this is the force. You applied some force F. You applied some force F, force vector. Now in this example, what you can see, that force vector is up in the north direction. You can draw like this also. And R vector is what? In which direction? East direction. So this is the R vector. So what is the angle here between R vector and force vector? 90 degree. You can see the angle here is 90 degree. Suppose this distance example, what will be our torque? Torque will be distance, that is 10, multiplied by force, that is 5, multiplied by sine theta. Angle is 90, so sine 90. Sine 90 value is 1. So how much you are getting? 10 5 ja 50. So what will the SI unit of torque? R is distance. Its unit will be meter. Force unit will be Newton. And sine theta is the ratio, no unit. So Newton meter. 50 Newton meter will be the answer. Correct. Now next thing that you need to understand, suppose for example that this is the center of rotation and there is a rod or anything, like this is a door. See, if I am pulling this door, is it rotating? No. Correct. Means suppose this is the center of rotation. If I am applying force at this point in this direction, suppose I am pulling, definitely this rod will not rotate. I am pulling. Will it rotate? No. Why? Because see, here you are applying force. This is R vector. This I can say this is the R vector. Here you are applying force. So this is the R vector. R vector and force vector in the same direction. R vector is parallel to force vector. Means theta is how much? 0 degree. So sine 0, 0. So torque formula was RF sine theta. RF sine theta. Theta is 0, sine 0. So it will become 0. There will be no torque. Because the object will not rotate. Correct. So always remember, if the force passes through the center of rotation, if the force or line of force passes through center of rotation, see this force, if I extend back, it passes through center of rotation, na? The object will not rotate. Like for example, this is my center of rotation, and you have applied force like this. You have applied one force here, you have applied one force here, and you have applied one force here. F1, F2, F3. They will ask what will the torque about O. So see, all these forces, that F1 is also passing through center of rotation, F2 is also passing through center of rotation, and F3 is also passing through center of rotation. So there will be no torque. Correct? Means if force or line of action of force passes through center of rotation, then torque due to those forces will be 0. Correct? Then torque due to those forces will be 0. So always remember. Next point, see some analog behavior you should able to understand. Like see, in linear motion what happens? Let's suppose there is mass, linear motion, 1D. You are applying some force. What happens? It accelerates. It gets acceleration. Similarly, in rotation, what happens? Suppose there is any object, it will have, like mass, it will have moment of inertia. I, moment of inertia. When we apply torque, suppose we apply torque, so force is replaced by torque. Mass is replaced by moment of inertia. So, like it is having acceleration, here you will get angular acceleration, alpha. What I am trying to say, like in linear motion, what we write, force equals to mass into acceleration. Here force is in rotation. If the object is rotating, always remember, like in linear motion, if we are writing force equals to mass into acceleration, in rotation, if the object is rotating, force is replaced by torque, mass is replaced by moment of inertia, acceleration is replaced by angular acceleration. So you should remember what is tau. Tau is torque, I is moment of inertia, alpha is angular acceleration. Similarly, lot of things are there. Like for example, here we have velocity in linear motion. In rotation, we have angular velocity. Angular velocity. Circular motion you must have studied, na? Angular velocity. Here we have momentum, linear momentum. Here we have angular momentum. What is this? Angular momentum. Achha, what was the formula for momentum? Mass into velocity. So what is the formula for angular momentum? See, mass is replaced by moment of inertia, I told, and velocity is replaced by angular velocity. So these things you should be able to learn, that how we replaced in rotation. Okay. Like kinetic energy. What we write? P square by 2m. We have now this formula. So here in rotation, what will the kinetic energy? If the object is rotating, what will the kinetic energy? P square by 2m. So P is replaced by L. So L square by 2, mass is replaced by what? Moment of inertia, 2I. Achha, kinetic energy in linear motion, what we write? Half mv square, half mv square. So here kinetic energy in rotation, what we can write? Half, in place of mass, moment of inertia. In place of velocity, angular velocity square. Okay. So these things you should know. Achha, first we will learn about moment of inertia. Moment of inertia. So what is moment of inertia? It is basically resistance against rotation. How much the object is going to resist if we are trying to rotate. Resistance against rotation. How much the object is going to resist if we are trying to rotate it. Correct? How we calculate moment of inertia? See, suppose this is the axis of rotation. See there, now from here it is important. Suppose this is the axis of rotation and there is any mass here. There is any mass here. At a distance r, this is the center of rotation. Then we define moment of inertia equals to mr square. I equals to mr square. Correct? This is how we calculate moment of inertia. I equals to mr square. Achha, suppose, for example, this is my center of rotation. At a distance r, there is one mass m, and again here at a distance 2r, there is a mass 2m, suppose. If I ask what is the moment of inertia about O, so due to this mass is at a distance r, so we will write mr square plus due to this mass, what is the moment of inertia? Mass into distance square. Mass is 2m, distance is 2r. Distance is 2r from the center of rotation, na? 2r square. So this 2 square will be 4, 4 2 ja 8. 8 mr square plus mr square, that is 9 mr square. Okay. So for a point object, the formula for moment of inertia is mr square. This you need to remember. Next, we have lot of cases that you need to remember the formulas for moment of inertia. Very important. Like moment of inertia. See, moment of inertia of. I am writing. Like they will give ring. There is a ring. This is a ring. Its mass is m. Its radius is r. They ask what is the moment of inertia about this axis, z axis, or the axis which is perpendicular to the plane of the ring, z axis. So moment of inertia about z axis is mr square. Correct? If they ask what is the moment of inertia of second disc, disc means like CD. Suppose there is a CD like thing. If they ask what is the moment of inertia of this, its mass is m, radius is r, about again this axis, z axis. So again moment of inertia about z axis is mr square by 2. Remember these values, mr square by 2. Then third, we have hollow cylinder. Hollow cylinder. Like this. This is a hollow cylinder. This is a hollow cylinder. Its mass is m, radius is r. This is the vertical axis. Moment of inertia about this, suppose this is z axis, whatever. So again its formula is mr square. If it is a solid cylinder, suppose this is a solid cylinder, solid means material is inside, mass is m, radius is r. So if they ask what is the moment of inertia about this vertical axis, mr square by 2. Correct. Fifth, if this is a hollow sphere, if they ask what is the moment of inertia about this axis passing through center, and diametrical axis. This is the diameter also, no? So moment of inertia about this axis, 2 by 5 mr square. These values just you have to remember. Sorry, if it is hollow, this is 2 by 3. 2 by 3. If it is a solid sphere, hollow sphere and solid sphere, you know the difference. Hollow sphere means plastic ball, solid sphere means fuse ball. So same formula will become 2 by 5 mr square. Seventh, if there is a rod, now this is very, all the things that I am telling now, I am telling only the important things. We have 20 formulas, but 7 to 8 most important I am telling. If there is a rod, mass of the rod is m, length of the rod is l. This is the center of rod. If you want to rotate the rod about this axis, about center. Understood? About center. So moment of inertia about this axis, is ml square by 12. But if you are rotating the rod about this axis, like this, okay, means if you are rotating the rod about this axis, end of the rod, then moment of inertia about this axis is I equals to ml square by 3. Very, important. This ml square by 12 and ml square by 3. So moment of inertia of rod about this axis is ml square by 3. Second, next thing, parallel axis theorem. What it says, that suppose, for example, this is the moment of inertia of rod about center of rotation. We know that moment of inertia about center of rotation is how much? ml square by 12. Just now I told. Now what parallel axis theorem says? That if you want to know the moment of inertia of any object around about the axis which is parallel to the central axis. See, I want to know the moment of inertia about this axis. I want to know the moment of inertia about this axis. Now, what parallel axis theorem says? That if you know the moment of inertia formula about the central axis, then the moment of inertia about any axis which is parallel to this is calculated as moment of inertia about central axis plus mass into distance between axis square. Like let's calculate moment of inertia about x. So moment of inertia about x will be moment of inertia about center, that is ml square by 12, plus mass into distance between axis. What is the distance? Total length of the rod is L. Distance between axis is what? L by 2. Distance between the axis is what? L by 2. So L by 2 square. So this will be ml square by 12 plus ml square by 4. You take the LCM. So ml square plus 3 ml square, 4 ml square by 12 means ml square by 3. See, it is coming ml square by 3. Moment of inertia about this axis will be ml square by 3, and this we have, I made you write also, ml square by 3. So this is parallel axis theorem. Next is perpendicular axis theorem. Perpendicular axis theorem. What is perpendicular axis theorem? It says that moment of inertia about z axis. What is z axis? Like suppose the object is kept in a plane. Suppose here I have kept the object. The axis which is perpendicular to the plane of the object. The axis which is perpendicular to the plane of the object, that we are calling z axis, is equals to moment of inertia about x axis plus moment of inertia about y axis. For example, there is a ring. See, try to understand. There is a ring. They are asking what is the moment of inertia about this axis, x axis. Okay. Now we know that moment of inertia about z axis, this axis, moment of inertia about z axis of the ring is mr square. But they are asking moment of inertia about x axis. Acha. So what we can write? Moment of inertia about z axis equals to moment of inertia about x axis plus moment of inertia about y axis. This is perpendicular axis theorem. So moment of inertia about z axis is mr square equals to moment of inertia about x axis plus moment of inertia about y axis. See, x and y axis are same now almost. It is the same thing. This is x axis. This is passing through the center and diameter. This axis is also what? Passing through the center and diameter. They are almost same. If you like see like this, so this is x axis, this is y axis. If you see like this, so this will be x axis, this will be y axis. So they are all same. So we can write moment. This is ix, iy is also equals to ix. Both are same. Moment of inertia will look same. So what we can write? Mr square equals to 2 times ix. From here, moment of inertia about x axis will come mr square by 2. So if they ask what is the moment of inertia of a ring about this diametrical axis, so it will be mr square by 2. Similarly, if they ask what is the moment of inertia of disk about this axis, see this axis, y axis, x axis, whatever, again same thing, moment of inertia about z axis equals to moment of inertia about x axis plus moment of inertia about y axis. About z axis we know for disk it is mr square by 2. So this will be equals to moment of inertia about x axis plus moment of inertia about y axis. And you know that x and y axis look same. So you can write iy plus iy or 2iy. So moment of inertia about y axis is equals to moment of inertia about x axis. This 2 will go there, equals to mr square by 4. So these are two important theorems, parallel axis theorem and perpendicular axis theorem. So this you should be able to know. If they ask the moment of inertia about z axis, it will be mr square by 2. If they ask moment of inertia about y axis or x axis, it will be mr square by 4. Next is radius of gyration. Radius of gyration, K. Now what is radius of gyration? For example, what I am saying that suppose this is a solid sphere, correct? If I ask what is the moment of inertia about this axis, this is a solid sphere. I made you write that the moment of inertia about this axis, suppose z axis, is how much? 2 by 5 mr square. Now see, what is radius of gyration? Very important thing. Radius of gyration means, if I keep the axis same, if I don't change the axis, but if I treat the sphere like a point object, suppose if I treat the sphere like a point object, so at what distance I should keep? See, what I am saying, if the axis remains same, and if I treat this solid sphere as a point object, this sphere is a point object, then at what distance we should keep so that we should get the same moment of inertia? So this distance from the axis is called radius of gyration. Again I am saying, if we take the same axis and assume that this solid sphere is a point mass, then at what distance from this axis we should keep this point mass so that we get the same moment of inertia? So this distance is called radius of gyration. So same, see what we have to do, same moment of inertia means what? See, now this is a point mass, na? Now this is a point mass. What is the, for point mass, what is the formula for moment of inertia? For point mass, moment of formula is mr square, m into distance square, distance is k, mk square. Acha, this moment inertia and this moment of inertia has to be same, because this is the definition of radius of gyration. At what distance we should keep so that we get the same moment of inertia? So moment of inertia equals to 2 by 5 mr square. So m cancel. So k value will come under root 2 by 5 r. So this is the radius of gyration of solid sphere, root 2 by 5 r. So see, very easy. You don't have to be complicated that much. If any object they ask na, what is the radius of gyration, what you do, like for example, they are asking what is the radius of gyration of disk. Correct? So disk, you know that moment of inertia about z axis is mr square by 2. They are asking radius of gyration. Just equate with this mk square. Just equate with mk square. So m will get cancelled. So k value will come r by root 2. They ask radius of gyration for ring. So ring moment of inertia about z axis, you know, mr square. Again you equate with this mk square. So m cancel, k equals to r. So radius of gyration of ring is nothing but r only. So this is all about radius of gyration. Correct? Next, angular momentum. Like linear momentum, in translation motion we have linear momentum P, and in rotation we have angular momentum L. What is the formula for linear momentum? mv. What is the formula for angular momentum? In place of m, there will be moment of inertia. In place of velocity, there will be angular velocity. And there is one more formula, always remember, for angular momentum, r cross p. R cross p. I will tell you what is this. For example, there is one object which is rotating like this. Suppose this is a CD. There is a CD and this is rotating, and there is one chima, ant. Here there is one ant. This will also rotate round and round. Suppose this linear velocity is v, correct? So if someone asks what is the angular momentum about O, so angular momentum about O will be, see what is the formula, r cross p, r cross p. Now I will tell you what are these things. R means from center of rotation, where is the point, where is the particle. So this is my r vector, this is my r vector. So here what you can see, acha, r cross p means a cross b is ab sin theta, so r cross p will be rp sin theta. So r, in this case r is what, radius. P, momentum means mass into velocity. Suppose mass of the object is m, mass of the chima is m, so m into velocity. Sin theta, here you can see theta is the angle between what, r vector and p vector. R vector is like this in the east direction, and p vector, p is what, momentum. What is the direction of momentum, direction of velocity. So p vector is what, this is p vector and this is r vector. Angle between them is 90 degree, so sin 90 value 1, so you will get mvr, mvr. See one more example. Suppose there is an object here, it is moving with v speed or v velocity here. Mass of the object is m, correct? You are here, this point I say O, okay? This distance is suppose h, from here to here it is h. They are saying when the object, this is example, when the object reaches this point, still it is moving, its velocity is constant, so v only. What is its angular momentum about point O? Try to listen. What is its angular momentum about point O? So what you can write, angular momentum r cross p. This is the formula. R, what I said, from center of rotation to the point where the object is, you write, you draw that vector, this is r vector, and this is what, p vector. Momentum vector is what, direction of velocity is direction of momentum, momentum vector is this. So what we can see, this is our r vector and this is our p vector. So what is the angle between them? Can I draw like this? See, any vector you can shift now. What I am saying, this is r vector suppose, or I am drawing here so that you understand better. This is my p vector because velocity is in this direction. So this is my p vector, and this is my, I can shift it parallel. So this is my r vector. So angle between r and p is theta, means this angle, theta. If this is theta, this is also what, theta, vertically opposite angle. So r cross p, can I write rp sin theta? So can I write p into r sin theta? So can I write p into r sin theta? See, this is r, this is theta, this is r cos theta, and this distance is r sin theta. See, this is r, this is theta. See, if I ask what is sin theta? Sin theta, what you will say? Sir, perpendicular by hypotenuse. Perpendicular means h, by hypotenuse means r. So cross multiply, r sin theta equals to h. So r sin theta is nothing but h. So our answer will be ph. This will be the angular momentum about O, ph. Correct? Magnitude I am taking. Direction you can calculate from basics. Vector. Direction will be perpendicular to r vector, perpendicular to p vector. Correct? Like this is r vector. This is p vector. So r cross p, it is coming what? Clockwise. Clockwise means in this example, if I ask a direction, so in this example, direction will be what? See, how to see the direction? This is r vector, or here only I will tell. This is r vector, this is p vector. We are doing r cross p, means from r we are going to p. This direction is what? Clockwise. Always remember, whenever it comes clockwise, direction is minus z axis. If it comes anti-clockwise, direction is what? Plus z axis. So minus z means this direction into the plane of the board. So here in this example, direction is what? Minus k cap. Clockwise. Now conservation of angular momentum. Conservation of angular momentum. What is conservation of? What was conservation of linear momentum? Conservation of linear momentum was there that if external force is 0, then what we can write? Total momentum initial equals to total momentum final. Momentum gets conserved. Similarly, if torque external is 0, if there is no net torque on the system, then total angular momentum initial equals to total angular momentum final. Means I initial, omega initial equals to I final, omega final. We can write. Correct? For example, what kind of question can be asked here? They will say that there is a disc. This is the disc. Mass of the disc is 1 kg. Radius of the disc is 1 meter. And this disc is rotating about this z axis with angular speed 1 radian per second. Okay. Now what we do, we gently put, so this CD is rotating. We gently put one chima here. Here, chima at this side. Correct? Mass of the chima is half kg. Very heavy chima, half kg, suppose. So if we gently put, what will the final angular velocity of the system? Final angular velocity means, now if I put gently chima will also rotate with the CD. Na? So what will the final angular velocity? Chima is heavy, not very light, half kg. See, what will the final angular velocity of? So if we take our disk plus chima as our system, so can I say there is no external torque acting on the system? No one is rotating rotating this object. This object was initially rotating only. Now no one is rotating or no one is stopping. So torque external is 0. So if torque external is 0, what I can say? Total angular momentum initial equals to total angular momentum final. Or initially, angular momentum is I omega. What was I initially? Then there was no chima. So I means only CD was there. I initial, if I say only CD was there. So what is the moment of inertia of CD? mr square by 2. mr square by 2. This is the moment of inertia of CD about z axis. Into omega. Into, this is I. Okay, this is I. So what I can write? Li, I initial, omega initial. So I initial, mass 1 kg, radius 1 square, that is 1 by 2 into initial omega 1. So how much it is coming? 1 by 2. This is initial angular moment. Final like moment of inertia, if I want to write, what is the final moment of inertia? So definitely mr moment of inertia of CD, mr square by 2. This will be mr square by 2 only. Plus now CIMA is also there. So of CD you have calculated the moment of inertia. Now you have to calculate the moment of inertia of this CIMA, about this. So CIMA is the point object. This is the center of rotation. This is the point object. What is the moment of inertia? M into R square, mr square. So mass of CIMA, that is half kg into radius square. Radius is what? 1. 1 square, that is 1. This mr square by 2, this was mass of CD 1, radius is 1. So 1 by 2 plus 1 by 2, 1 by 2 plus 1 by 2, this will 1. Now what I am saying, L initial equals to L final means I initial, omega initial equals to I final, omega final. I initial, omega initial. See, L initial, I initial, omega initial is coming 1 by 2 equals to I final. I final is coming 1 into omega final. So omega final will come out to be 1 by 2. So finally, final angular velocity will become half radian per second. Half radian per second. Initially it was 1 radian per second. Now if you put that CIMA, it will become half radian per second. So this kind of question comes. Just what you have to do, just you remember this thing, that initial angular momentum equals to final angular momentum. This is important, or initial, these two things is important. Rest is calculation. Initial angular momentum equals to final angular momentum. Correct? Now see, there are like n type, like some kinds of motion which we call translation motion. Translation. What is translational motion? See, like suppose this duster, this is a duster, this is going with v velocity. Suppose this is the center of mass. So this is the velocity of center of mass. So what will happen? All the points will move with same velocity. Like suppose this is my pen. This is moving with this velocity. So all the points are what? Like if I say about this point, this will also move with v velocity. This will also move with VCM. So this is translation motion. Next is rotation. Rotation motion. In rotation, what happens? Suppose there is a disc, there is a CD, or there is any particle which is rotating like this. This is the center of rotation. The particle is rotating like this. Correct? So if I ask what is the linear velocity here, what is the direction of linear velocity, you will write the tangent. Correct? This object was rotating with angular speed. Angular speed is omega. Angular speed is omega. If someone asks what is its linear speed here, so v, this is the v. This v is the linear speed. And you must have learned in like circular motion that v equals to r omega. V equals to r omega. You know these things. Here if someone asks what is the linear velocity, again tangent, same value, v equals to r omega. Here if someone asks what is, so v equals to r omega. Correct? Correct? So these things you should remember, that if some object is rotating with omega, what is the angular speed? Omega. If someone asks what is the linear speed, so linear speed is always tangent or tangential speed, which is always tangent to the point. Here tangent, here also tangent, here also tangent. And this speed is v equals to r omega, v equals to r omega, v equals to r omega, where r is the radius, means from the center of rotation, the point where you are asking the linear speed, that distance, this is r. Here you are asking the linear speed, so this is r, and omega is the angular speed. Now what happens when we have a mixture of translation as well as translation plus rotation? Means what is happening, like tire you beat now like this. Some like small kids will play like this, that there will be tire, they will beat like this. So tire is rotating also and tire is moving forward also. It means it is rotating plus it is moving forward, translation motion. Like this duster was moving forward, translation motion, and this tire is rotating also, rotation. So try to understand this concept. So what will happen? Suppose the disk was moving forward with some speed VCM. This is velocity of center of mass. Since it is performing translation motion, all the points will move with same velocity. This will also be VCM. This point will also move with VCM, because in translation motion we know that all the points move in the same direction with the same velocity, VCM. Here also if someone asks, VCM. Correct? But since the object is rotating also, with omega, due to rotation, what we can write? What is the speed? Like at this point, if someone asks what is the speed, so I will write r omega. Here also r omega. Here also r omega. Due to this speed I am writing due to rotation. This VCM I have written due to translation. But it is doing translation as well as rotation. So due to rotation, r omega will be here, r omega will be here, r omega will be here. Similarly, r omega will be here. See now, due to rotation, just now I told r omega here, r omega here, r omega here. So if someone asks that what is the total speed, so you can say now what is the total speed of point A? So you can say r omega plus VCM. Now see, here we have 2-3 conditions. If VCM is, see here, this point, focus on this point. If VCM is greater than r omega, this case is called forward slipping. Forward slipping. If VCM is less than r omega, this case is called backward slipping. But they ask this case, very important, that if VCM equals to r omega, this is called pure rolling. Pure rolling. So what will happen? If VCM equals to r omega, this point will be at rest. See now, this velocity cancelled. So this point is at rest, or the net velocity of this point, V net of this point will be what? 0 of point P. V net of point P will be 0. Understood? So always remember 2 things. Again, we have less time. So pure rolling, In pure rolling, what happens? Velocity of center of mass is equals to r omega. This point you have to remember. And second point, acceleration of center of mass equals to r alpha. Acceleration of center of mass if the object is accelerating. Suppose they have given some case in which the object is accelerating. So acceleration of center of mass equals to r alpha. Alpha, I told now. Alpha is what? Alpha is what? Tangential, sorry, angular acceleration. Angular acceleration. Correct. So what is angular acceleration? Suppose there is a CD. It is rotating with some omega. We are rotating the CD. It is rotating with omega. Now we rotate it fast. Or its speed will increase. The angular speed will increase. So we define angular acceleration. How much? How much? Just like we define speed, normal acceleration. We define normal acceleration how much? dv by dt. Acceleration equals to dv by dt. Change in speed divided by time. Similarly, we define angular acceleration as d omega. How much angular speed is changing in how much time? This is angular acceleration, d omega by dt. So this you should know. Acceleration of center of mass equals to r alpha. Okay. Means what I am saying, if the object is accelerating also, if this object is accelerating also, this object is moving, na, translation motion. Suppose this is accelerating also. This is acceleration of center of mass. AC, acceleration of center of mass. And the object is rotating also. And in that also, it is rotating, like initially it is rotating slowly and later on it rotates fast. So it will have angular acceleration. So always remember, whenever we have angular acceleration, we define one this tangential acceleration at. This is our at. And what is tangential acceleration? At equals to r alpha. This is due to rotation. This tangential acceleration came just due to rotation. If the object is rotating and if the object is changing its angular speed, we have tangential acceleration which is equals to r alpha. Now if the body is in pure rolling, so this is due to translation motion. Here we have acceleration of center of mass. If the object is in pure rolling, always remember that acceleration of center of mass equals to r alpha. R alpha. Pure rolling. So most of the time they will ask pure rolling case. So acceleration of center of mass equals to r alpha. Now pure rolling, what they ask, some important things you write down. What they ask, pure rolling. Pure rolling. If the object is doing pure rolling. So pure rolling means what? Translation as well as rotation. So if they ask what is the kinetic energy in pure rolling. So kinetic energy in first translation, what we can write? Half m velocity of center of mass, half mv square, plus kinetic energy of rotation, half. In place of mass in rotation, what we replace by? Moment of inertia. In place of velocity, what we replace? Angular velocity square. Now we know that VCM equals to r omega in pure rolling, in case of pure rolling. I told you what is the condition for pure rolling. Velocity of center of mass equals to r omega. So what we can write? Omega equals to, from here, omega equals to VCM by r. VCM by r. If I place here, so half mv square half m VCM square plus half I omega, that is VCM by R, half VCM by R square. So if you take half mv square common, half m VCM square common, it will be 1 plus I, see, what is I? mk square. What is I? In place of I, can I write, in place of I moment of inertia, can I write mk square? So half m VCM square I have taken common. So 1 plus half m VCM square k square by r square. This, see, I have proved, just you need to remember that if the object is doing pure rolling, they will ask directly like this. If the object is doing pure rolling, correct, what is the kinetic energy? So kinetic energy, the formula half m VCM square bracket 1 plus k square by r square. This is the kinetic energy in pure rolling. Okay. Last 5 minutes I will take. See, smooth inclined plane. Suppose that we have smooth inclined plane. Direct I am writing the formulas. We don't have time. Suppose like we have smooth inclined plane. This is theta. This height is h. There is one object like this. If I release this object, with what velocity it will come down? With what velocity? Velocity at the bottom. So always remember velocity at the bottom formula. See, again I am not deriving, I am just telling the formula. Velocity at the bottom equals to under root 2 GH. They ask this question. They ask what is the acceleration of center of mass. This acceleration of the object. So acceleration of center of mass is nothing but g sine theta. Correct. But if we have rough inclined plane, rough inclined plane, means same situation, but now the plane is rough. This height is h. You are releasing any ball or any object like this, and this plane is rough. Okay, rough. Then they ask same question. What is the velocity at the bottom? So velocity of the bottom, you write formula under root 2 GH divided by 1 plus k square by r square. K will be the what? Radius of gyration of this object. R is what? Radius of that object. Okay. So under root 2 GH divided by 1 plus k square by r square. They ask what is the acceleration of center of mass? With what acceleration it is going down? So g sine theta divided by 1 plus k square by r square. This is the acceleration of the object. See the difference. Here acceleration was only g sine theta. Here acceleration is what? G sine theta divided by 1 plus k square by r square. Here velocity was at the bottom was under root 2 GH. Here velocity is under root 2 GH 1 plus k square by r square, means 1 plus k square by r square factor is coming. Okay, so go through these formulas. 80% chance that directly, if you remember these formulas, the important formulas, they will give the values, you have to put the values and you will get the answer. Okay, sometimes they ask conceptual question that you have to practice and all, what you have studied in 1 year and that what you are practicing right now. Okay, so all about, this is all about rotation. Okay, so try and revise. Okay, thank you.